before we dive into the statement. It's far more persuasive to sort out what molecular gasoline pedals are. The Big Hadron Collider LHC, operated by CERN, is a 17M ring of superconducting magnets. In addition, it's the world's most prominent and noteworthy atom smasher. It represents the pinnacle of human achievement. As a matter of fact, it's so powerful that it could reproduce the precise states of the first moment on Earth. But could the system intended to open the mystery of the universe hold the key to something truly specific? Founded in 1954, CERN is one of the world's most famous research institutions with 23 member states and countless researchers. It's a place for collaboration and innovation. The LHC is CERN's principal undertaking, but it is only one part of a large organization of gas pedals and tests. Consider a route not so much for automobiles or people, but for subatomic debris in a trial of aptitude, patience, and space itself. The LHC accelerates protons to almost the speed of light, sending them on a collision course that reflects the energy of the universe. Right after the Big Bang, the impacts create temperatures much hotter than the core of the Sun. A big number of magnets guide the protons on their journey, while complex cooling structures keep the magnets at temperatures colder than space. The beams in the LHC are made to crash at 4 locations around the gas pedal ring, connect with the spots of 4 particle detectors: Atlas, CMS, Alice, and LHCb. Each fills a specific purpose, investigating different components of particle physics. Together they act as large cameras taking pictures of these collisions. Scientists then sift through the debris, searching for signs of the elusive Higgs boson, also referred to as the God particle, and other anomalies that could provide clues about the universe's essential building block. By focusing on the microcosm, we gain insights into the universe, but with every solution comes another question, and with every discovery another challenge emerges. The LHC is not just a scientific instrument, it's an exhibit of human curiosity and progress. It represents our entrepreneurial mission for knowledge and our desire to understand the key forces that shape our universe. But as we push the limits of what we know, we must also consider the more profound and existential questions that arise. What are the risks of probing the unknown? Could our quest for knowledge inadvertently unleash powers we have no control over? Within the sacred halls of CERN, where the boundaries of human knowledge are constantly pushed, a revelation has arisen that sends a shiver down the spine of even the most pro scientists. Brian Cox, a former scientist at CERN and a voice of expertise in the field of particle physics, has recently said something that has left the world both enthralled and uncomfortable. Cox's words resound with chilling clarity. The purpose of CERN's Large Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right, a small version of the very event that gave birth to our universe. The physicist also went on to explain the ramifications of this aim, highlighting the LHC's immense potential for making new discoveries. This includes its ability to uncover the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a vast portion of the universe. Imagine holding the power of creation in your hands, the capacity to summon the very essence of the universe. It's an attractive possibility, but one fraught with danger. The mini Big Bang isn't just a theoretical idea, it's a very real phenomenon within the LHC. The temperatures, the pressures, the raw energy, everything recreates the conditions of the universe's birth. It's like standing at the dawn of recorded history, witnessing the birth of life itself. Yet with such power comes responsibility, and the question looms: what if something goes wrong? In fact, something did go wrong back in 1978 Russian physicist Anat Borsky encountered a disaster that would forever change the course of his life. While working on the U-70 synchrotron at the Institute for High Energy Physics in Pino, Russia, a failure caused his head to accidentally enter the direct path of a proton beam. The beam, with a force that defies perception, passed through his skull, entering the back of his head and exiting through his nose. Borsky's experience was harrowing. He saw a flash brighter than 1,000 suns, but had no immediate concerns. The beam's path left a trail of destruction, burning tissue and bone, but he remained conscious and even walked to the center for treatment. The outcome was both troubling and remarkable. The beam caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. Remarkably, Borsky's cognitive abilities remained intact, and he continued his scientific career. This incident serves as a reminder of the immense power and potential dangers of particle accelerators. The dangers of a particle smasher like the LHC are not to be underestimated. The potential for catastrophic reactions, the very fabric of existence being altered. These are not the stuff of science fiction, but real concerns voiced by respected scientists. One of the most unsettling and captivating concerns related to the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are giant vacuum cleaners, devourers of stars, and mysterious entities lurking in the shadows of our universe. The fact that the LHC could potentially create such a phenomenon, even on a small scale, is inspiring to both the public and scientists. Life. Could this black hole eventually growing out of control and swallowing the Earth from within? Scientists at CERN have reassured the public that any black hole created would be unstable and disappear very quickly. Nonetheless, the remote possibility has sparked debates, fears, and a sense of awe at the energy we wield. It's important to understand how the LHC might create a black hole. It's all about the basic mechanics of particle accelerators. When protons are smashed together at almost the speed of light, the energy produced is so immense that it distorts the fabric of spacetime itself. Imagine a trampoline stretched tight, then a heavy object dropped onto it. The material bends, and if the object is heavy enough, it could create a well so deep that anything nearby could be drawn into it. This is an analogy for what could happen at the LHC in the realm of quantum physics, where the laws of the universe are both strange and wondrous. There's speculation that extra dimensions might be hidden within our reality. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a small black hole. This peculiar dance of particles has even caught the attention of some respected scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario in which the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic event known as vacuum decay, an event that wouldn't just destroy Earth but could potentially destroy the entire universe. The renowned English cosmologist and astrophysicist Sir Martin Rees also expressed concerns about the experiments conducted at CERN. In his book on the future possibilities for mankind, he explored the potential dangers of particle smasher experiments, including those at CERN. His words weren't just cautious, they were filled with a sense of existential dread. He examined a worst-case scenario in which a failed experiment could trigger a phase transition that would ripple through the fabric of spacetime, resulting in a disaster that would engulf the entire universe. Rees' worries were not limited to theoretical musings. He assigned a low probability to these catastrophic outcomes, but nevertheless, he argued that even a small chance warrants serious attention. The stakes are high and the margin for error is razor thin. The scientists at CERN have run simulations, analyzed theories, and taken every precaution to ensure the safety of the LHC. In fact, Brian Cox himself emphasized the importance of these measures, acknowledging the inevitable concerns and questions surrounding the LHC's activities. He reassured the public that there are rigorous safety protocols in place, thorough reviews and procedures to ensure the LHC's operations are executed with the highest degree of attention to detail. Cox reassured the public that the energies involved are well within what the Earth naturally experiences and that the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so tiny and volatile that it would deplete rapidly in an explosion of energy, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a fleeting moment of cosmic wonder, a brief glimpse into the void, and then gone. Some have taken the idea even further, speculating that the LHC's experiments could open a gateway to another universe or dimension. While this idea is largely dismissed by mainstream scientists, it has captivated the imagination of many and become a subject of intrigue, fear, or even fantasy. What lies beyond our universe? Could we accidentally unleash forces or entities that we don't understand? The idea of opening a door to hell has even been sensationalized in various media, fanning the flames of uncertainty. But how did this idea come about, and what does it mean in terms of scientific exploration? The idea of extra dimensions isn't new in physics. String theory, a leading contender for a unified theory of everything, suggests that there may be more than the usual 3 dimensions of space and one of time. These extra dimensions could be compactified or hidden from our perception, but they might in theory be accessed or revealed under intense conditions. Now imagine the LHC as a giant key opening doors that have been locked since the beginning of recorded history, when protons collide at energy never before achieved on Earth. They could in principle create ripples or waves that probe these hidden dimensions. If these dimensions exist, the LHC might indeed discover them. However, before we get too excited with wild speculation, it's important to remember that while the LHC is certainly powerful, there's no definitive proof to suggest that it will open a door to another universe, let alone to hell itself. Nevertheless, the allure of the known, combined with the mysterious nature of quantum physics, ensures that such ideas will continue to captivate the public imagination. So should we be concerned about the LHC and its potential risks? It's easy to be swept away by sensational headlines and fears of global disaster, but the reality is that the scientists at CERN are highly aware of the risks involved. They've taken every precaution to ensure their experiments are safe, and they continue to monitor and test their work with the highest level of diligence. The potential benefits of the research, the breakthroughs in our understanding of the universe, the discovery of new particles, the exploration of dark matter, are truly remarkable. It's not only a showcase of human ingenuity but a window into the very heart of the universe. But, like all great advancements in science, comes with its share of risks, and we must approach it with a balance of wonder, respect, and caution. The Large Hadron Collider represents the frontier of scientific inquiry, where theoretical physics meets experimental reality. Its true potential to answer fundamental questions about the universe, including the origins of mass and the nature of dark matter, is unprecedented. Yet despite rigorous safety measures and extensive simulations, the LHC still inspires a sense of mystery and fear in some. The sheer scale of the machine and the energy it generates are inspiring, and each new experiment opens the door to uncharted scientific territory. While most scientists remain confident about the safety of LHC experiments, there are undeniable uncertainties. What if new, unexpected anomalies arise that challenge our understanding of physics and the laws of the universe? The LHC pushes the boundaries of human knowledge and tests the limits of our control over the natural world as particle collisions mirror conditions hidden since the Big Bang. The significance of these experiments grows, raising existential questions about the potential consequences of altering the very fabric of the universe. Regardless, the LHC's achievements in particle physics have been monumental. It has led to the discovery of the Higgs boson, advanced our understanding of the Standard Model, and opened pathways to potential breakthroughs that could eventually shape our technological future. Yet the quest for knowledge remains one of humankind's most ambitious endeavors. The journey of scientific discovery is rarely without risk, and the LHC is no exception. Its experiments delve into areas of physics where intuition no longer applies. The Large Hadron Collider LHC, a towering marvel of modern science, stands as the world's largest and most powerful particle accelerator located at CERN near Geneva, Switzerland. It serves as the flagship project of particle physics, pushing the boundaries of human knowledge about the fundamental components of the universe. The LHC is designed to simulate the high-energy conditions that existed just moments after the Big Bang, making it a pivotal instrument in understanding the evolution of the cosmos. In this immense